Welcome to homework.
So here in this problem we are given a piston cylinder arrangement and the mass of saturated water vapor, it is given as 1.2 kg, and the initial condition P1 is 200 degrees Celsius and the temperature remains constant, and the heat is now transferred to the steam and it expands reversibly and isothermally, and the final pressure we are given as 800 kilopascal. And we have to determine two things. First of all, the heat transferred, and the next is the work done during the process. So before proceeding with the solution, I'll be making a TS diagram of the given process. So this is the TS diagram, and this one is state 1 and this one is state 2. So now we'll be using the table A4 and A6 to find the required input data. So T1 we are given as 200 degrees Celsius and it is saturated vapor. Initially it is saturated vapor as per the question. So by using the table as given in the book, we can calculate the specific internal energy and specific entropy corresponding to this temperature 200 degrees Celsius. So U1 from the table will get it as 2594.2 kilojoule over kg, and the specific entropy will get it as 6.4302 kilojoule over kg Kelvin. So next again we'll be using the table to calculate the specific internal energy and specific enthalpy at state 2. So pressure P2 we are given as 800 kilopascal, and it is given that process is isothermal process. So T2 will be equals to T1 and that is 200 kilopascal. So again by using the table as per given in the book, we'll get the value of U2 as 631.1 kilojoule over kg, and specific entropy it will be 6.8177 kilojoule per kg Kelvin. Now first we have to calculate the heat transferred. So we know that heat transferred is equals to T minus delta S. So T is 200 degrees Celsius, but we have to convert this thing into Kelvin. So we'll get it as 473 Kelvin, and delta S will be M times delta S, it will be M times S2 minus S1. So mass we are given as 1.2 and S2 we have obtained as 6.8177 kilojoule over kg Kelvin, minus S1 is 6.4302 kilojoule over kg Kelvin. So by solving this, we'll get the value of Q, or the heat transferred, as 219.9 kilojoule. So this is the value of Q. Now next we have to calculate the work done during the process. For that we'll be using the first law of thermodynamics for the closed process, for the closed system. So Q in, it will be equals to W out plus change in internal energy. So from here W out will be equals to Q in minus delta U. So Q in is 219.9 kilojoule minus delta U. So delta U is the internal change in internal energy, that is M times U2 minus U1. So we can plug this value here. M here is 1.2 kg, so 1.2 kg times U2. So U2 we have this is U2, so 2631.1 kilojoule over kg minus U1 is 2594.2 kilojoule over kg. So we're going to solve this and we'll get the value of W out as 175.6 kilojoule. So this is the final answer. I hope you got the problem. Thank you.